Okay, today we're going to do some examples of synthetic division. Okay, so I have set up this problem. We are dividing this particular polynomial by x minus 2, and so remember there will be a sign change. We always divide by the potential 0. X minus 2 is the factor, the potential 0 is 2. Our first step is just to bring down the 1, and then we're going to multiply 2 times 1 and put my answer there. Then I'm going to actually add those two and I get 0. And then I'm going to repeat. I'm going to do 2 times 0, put the answer there, and I'm going to add and I get negative 13. And then I'll do 2 times negative 13, which is negative 26, and I add and I get negative 36. So what we know about this, first of all, x minus 2 is not a factor. Because there's a remainder, x minus 2 is not a factor. And 2 is not a 0. But what we do know is that f of 2 is going to be negative 36, which corresponds to the point 2, negative 36, when we get around to graphing. This right here is what we call the depressed polynomial, and it represents x squared plus 0x minus 13, or just x squared minus 13. And then our remainder is negative 36 over x minus 2. So this is the answer to the division. But we learn a lot just from that division. Let's do another one. Okay, for our next example, we're going to divide by a complex number. 2 minus I is a complex number. And if you recall, all complex numbers can be written in the form with the I. And so, notice I put my coefficients in my division, but I left a lot of space because we want to use the complex numbers. So what I can do is, since none of these are really complex or don't have an I part, then they're always plus 0I. And so now we're going to divide using that. Now you don't have to do it that way, but I will explain it this way, and then next time if you want to adjust, you can. We will need scratch paper. So here we go. The first step, I'm just going to bring down that first number. Well, it's 1 plus 0I. Well, that's just 1. I don't really need 0I there, but I'm going to go ahead and put that's 1. Okay. Now the second step is I need to multiply the 2 minus I times 1. Well, anything times 1 is whatever it is. So 2 minus I times 1 is 2 minus I. And now here is where the imaginaries come into play. I get to combine the like terms here. So I'm going to have a minus I and a minus 6. So a negative 6 minus I is my next term. Alright, so now I'm going to multiply again. And this is where my scratch paper comes in. I'm going to have to multiply 2 minus I times negative 6 minus I. And I'm going to need to use scratch paper to do that. So I'm going to do that over here. Negative 12 minus 2I plus 6I plus I squared, which gives me minus 12 plus 4I, and again I squared is negative 1, so that's going to be minus 1. So that gives me minus 13 plus 4I. So when I do it, I'm going to put it right here. Minus 13 plus 4I. Okay, so now I've got to add those two together. So I'm going to have a 4I, and 21 minus 13 is 8. Is that right? Okay, so now I'm going to multiply again. So this time I'm going to do 2 minus I times times a plus 4i. Okay, so when I multiply this, I get 16 plus 8i minus 8i minus 4i squared. Okay, and guess what? The 8i's go away. I squared is negative 1, so that's going to become a plus 4. So I have 16 plus 4, which is 20. So when I multiply, I get 20. And technically that's 20 plus 0i. I don't need the i's. And I get a 0 for my remainder. So the question is 2 minus I a 0? Yes, it is. 2 minus I is a 0.